Here is another example of force vector. I know that this vector is a vector of force because it is measured in newtons. So this vector is 15 newtons long. Now let's identify its x and y components. And first we need to show them on our system of coordinates. My task over here is knowing the length of the force vector to calculate the length of its x component and y component. Considering that I know the angle between my vector, force vector and the horizontal line, I can define the cosine of this angle as the ratio between the adjacent side to the hypotenuse, like this, which allows me to calculate the magnitude of my x component of the vector as 14.1 newtons. But there is an important point. The x component over here is pointing into the negative direction. So I need to identify the fact that this particular vector is pointing into the negative direction, and I do it with a negative sign. X component of the vector is minus 14.1 newtons. And this is an important point to understand, that the magnitude is 14.1. The minus that we see right in front of the number is not a measure of how big is the force. It is the identification of the direction in which the force is acting. Our force of minus 14.1 newtons would be just as big as, or if as strong, if you prefer this term, as the force of positive 14.1 newtons. This sign in front of the number only identifies that this vector is pointing into the negative direction. And the sine of this angle of 20 degrees would be the ratio between the opposing side to a hypotenuse. And considering that my opposing side of this right triangle is equal in magnitude to my y component, I might as well put my y component here in the numerator. So the magnitude of my y component will be equal sine of the 20-degree angle times 15 newtons of the length of the vector itself equals 5.1 newtons. My y component vector is pointing into the positive direction, so I do not need to change the sign to identify otherwise. Okay, here is another example of the force vector. And by the way, you need to understand that the same principles can be applied to calculate the xy components of the velocity vector or acceleration vector. But here we have force. So let's identify xy components of this force. Well, the cosine of the given angle here can be identified as the ratio between the adjacent side to hypotenuse, and we do it like this, which allows us to calculate the magnitude of the force, x component of the force, as cosine 30 times 25 equals 22 newtons. So we know that the magnitude of this vector is 22 newtons. But once again, it points into the negative direction, and we need to identify it in our answer. X component of this force vector is equal minus 22 newtons. The 22 newtons is the magnitude of the force. The negative sign in front of the number 22 identifies that that particular vector points into the negative direction. The negative sign in front of the number does not make this force smaller. The force of minus 22 is bigger than the force of 10 newtons, even though the 10 is positive. Understand that in physics, the negative sign in front of the number identifies direction, not the magnitude. Only numbers represent the magnitude. The sine of our given angle of 30 degrees is the ratio between the opposing side and the hypotenuse, so we can put it like this, which allows us to calculate the magnitude of the y component of the force as the sine of the 30-degree angle times 25, the hypotenuse, which equals 12.5 newtons. But once again, considering that our y component vector is pointing into the negative direction, we have to present our information in this form. The y component of this force vector equals minus 12.5 newtons.